would be best if, I mean, if you'd like to introduce me, I can introduce myself. And if you can give me the ability to share my screen, then we can start from there.
I think you can share a screen.
All right. Okay. There you go. Okay, you should see the GraphQL. All right, there you go.
Oh, good.
Okay, well, everyone, hello again. My name is Oleg. I'm the developer behind Starknet Indexer. Just like the name tells you, that's what it does, right? It indexes events and transactions emitted by Starknet smart contracts. It is similar in functionality to other indexers that you may be aware of, like the Graph or other products out there, but it differs in its approach. Our indexer stores all of the events and transactions. It makes no distinction among the contracts, and it decodes all the data. We store all the data in decoded format: transaction data, function inputs, arguments, events, and event parameters. We decode them per contracts ABI, and we store it in a relational database. We do it so that you don't have to do anything else but run a query against this data. So contrary to other indexes that employ secondary processes that read events, decode them, sum them up, and then present, we already do this job for you. So so you can consume the data right away, and there are two ways to consume it. The way that we have it available right now is through GraphQL. GraphQL is many of you may be familiar with it. It's a very simple, very nice way to represent queries and combine queries, and those queries are run against the relational data that represent your events and your transactions. So without further ado, we can start looking at the GraphQL IDE and see what you can do with GraphQL. Does that sound okay for everyone, or do you need more introduction? I mean, I assume that if you're at the hackathon, that you're developers, right? And developers do need to present data to the end users, right? You need to not only send transactions to blockchain, but you also need to consume events. You need to decode them and present to the end users, right? You also need this data to analyze, and there are many ways to analyze this data, right? You can simply run a query and see it in your IDE, or you can consume it by your front-end application via an HTTP call, or you can aggregate and sum up this data. So let's try a few examples, and I hope the examples will show exactly what you can do. So we'll start with a simple query that combines two requests to the database. You see on the left is an Explorer. Explorer shows all the queries available to you, and basically every table in the database is presented by a few GraphQL queries that you can run against it. For example, an argument, for the lack of a better name, is data of your events, right? So smart contracts emit events within a transaction. Events have data attached to it, right? So we normalize all this data and we put event data into a separate table that we call an argument, right? So An argument has obviously a name, a type to it, right? And the type could be a felt or it could be a struct, a tuple, um, um, or any other value, right? Or an array, right? And we also decode it into a decimal. And I'll show later on why you need the decimal. You need it to run aggregation queries and sum them up or count. And each query has a where close filter, right? So you can select for a specific argument where its name equals to something, right? Or you can select for a particular value or a particular decimal representation of your value. Let's say you want to select all of the events whose arguments have a specific name and whose value, let's say, is less than some number, a million, for example, right? So in the Explorer, you can just flip open those queries, you can explore them, and you can use them to, by clicking on those check marks, you can use them to formulate your query, right? So the GraphQL IDE opens up with a few example queries. So let's just start from the beginning. The first query I call mint and deploy 100,000. It queries for a block whose number is 100,000, right? For all the transactions of type deploy, and also it gets you all mint events of a particular contract, right? So it's an example of how you can put two requests within one GraphQL query. It's very useful for your, for example, for your front-end application, right, where you want to show several tables and several numbers on the same page. So instead of hitting a REST API so many times, you can achieve the same within one query, right? So on the right, you see the result, right? You see all of the mint events of the contract. And what's very useful is that you see arguments or data of this event already decoded, right? So if you just called a sequencer or a Pathfinder API, you of course would get the events, but events have their data in bulk binary format, right? You just get an array of binary data. And if you apply an ABI of this contract to this, then you can decode it and you can present them nicely and put names to this data, right? So here you have an event mint with three arguments named sender, amount 0, amount 1, and so on. And you see that some of the amounts are of type struct uint 256, right? And we present it as a low-high value of uint 256 and also decode it into decimal so that you can consume it by your app and sum it up. And it's much easier to work with decimals than with a hex representation of your values. So you see an array of events, and also you see that block 100,000 in the end, right? So another query simply gets you block 100,000, right? So let's run it. You get the whole block, right? And again, you have values here decoded, right? You see all of your transactions. You see transactions with their smart contract function like execute, and the inputs to this function are also decoded, right? So instead of a bulk binary array, you see to, selector, call data as an array of field 3, and so on and so forth. I suppose that querying blocks is not that useful. You probably want to query for specific events of your contracts, right? So the way to do it is you query a table called event, right? So in this query, I don't know if you see it well on your screen, the query mint is querying event, right? And in the where clause, you put the name mint and a particular and your the address of your smart contract. So here we just limit the result to 1, right? So let's run this query. And by the way, all of the queries are represented by in the Explorer, right? So if I want to add another value in the return, right? If I'm interested not only in argument name type value, but something else about the event, then I can add, ID to it for the event, perhaps also a transmitter contract and so on, right? And of course, I can modify all the workflows right here in the editor, right? So very nicely, you can click and edit in the Explorer and have your query text update here on the fly, right? So let's run this query. Mint will return one event of your contract, named mint, right? And here you have all the arguments, right? So that's already more useful for you as a developer, because you can query immediately for all of your events, and you can explore them in a decoded form. Now, the next thing to see are complicated structs, because sometimes call data and event data is represented in structs and in arrays. And very often when you use a proxy contract, you need to use your implementation contracts ABI to decode this data. So the next 3 queries use this feature, right? So I can look for that particular input to a function, right? So this query is looking for a function input whose name is index and x for all transactions of this particular smart contract, right? So I have this contract address, and I limit my input to just 1 for demonstration. And this is your decoded input, right? You have your struct whose value has a field index and 2 values, x and y, right? And further in, you can select within a JSON payload of your value, right? So here, values is represented by an array, right? So here you can, in the next query, you can select element 1 of your value, right? So this index x and y will get you that particular field, right? Now, how do we get to this value? We get it because we store all the contracts ABI, right? So the next query, row ABI, will show you exactly that, right? So I'm calling row ABI of this contract, and this is the implementation contract. And this row ABI defines that struct, index and values, and its positions within the bulk binary array of data. And that's what helps us to decode this data and present it to you in the form that you just saw, right? So so that's already useful, right? I hope, where you can select particular values of arguments of your contracts and of your function calls. But what you really want to do, we assume, is to analyze this data. By analyzing, I mean, you need to know, for example, a total value locked in your contract, right? Or an amount of assets in a particular address, right? So the way to do it usually is to analyze all of your events and sum them up. For example, to see a number of assets or a value of a certain asset in a given address, you would select all of your, you would look for all of the transfer events where a destination is that address, and you want to sum up all of those values, right? In order to do that, you need to run so-called aggregation queries. Those of you who are familiar with SQL, you know that in SQL it's a quite trivial, it's a trivial thing to do, right? You do a select value group by a certain parameter, let's say an address, right? And that gives you a view into sums of values per address, right? So a similar thing you can do here. You can run so-called aggregation queries, right? So in this query called TVL, total value locked, I run an argument aggregate query, right? So if I scroll down in the Explorer for that query, for the TVL query, shows that I use the argument aggregate query, right? So argument has a query where I can select a particular argument, and I can also aggregate within the argument. So this query is different in a way that it gives you a where clause where you select your event and name of your argument, but also it gives you aggregate functions like average, count, max, and so on, right? So I selected an average, and that's where this useful decimal representation comes into play, right? So in order to sum up your values, you need to have them in your decimal representation, right? SQL doesn't do it quite well. It doesn't know how to sum up hex values. So here for aggregate functions, I selected all of them available: average, max, min, and so on, right? You can also do standard deviation, but it's not useful here. So I selected sum, right? And I also put in a where clause, right? A where clause says that I want to sum up arguments of event whose name equals to mint, whose transmitter contract is my contract address, and the name of my argument is amount 0, right? So that will sum up decimal values of all mint events of a particular smart contract, right? So in this example, and it's taken as an example from one of the dApps being developed, that gives you a TVL or a part of TVL for a particular contract. Let me run this query, and it should give you a nice large number for that TVL. So this is an example of analysis that you can run against your data right away. And by the way, data is up to date. So the moment we get a block from the sequencer, we parse it, decode it, and we put it in the relational database. So between the block being minted and being available, perhaps a second or two passes. So right here, after running the aggregate, I see that the maximum value is this large number, and I see this sum that represents my TVL. So things like that are usually done by secondary indexing processes in other products like the Graph, but we decided to have Postgres do it for you within a SQL query. So data is immediately available for you to consume. I'm going to pause for. I've been rushing because I have very little time to present, and I hope that I'm giving you an idea of how to use the indexer. But if you have any questions, then raise your hand right now. If let me know if I'm making sense. Anybody? No? All right, so let me continue. Okay, so we find those aggregate queries are very useful because you can sum things up, you can count number of transactions, right? And right away you can use this data, right? So for example, this query uses daily mint, right? It queries amount of minted assets per day, right? So here we use the last 3 days, right? Those are numbers of minted assets for July 5th, 4th, and July 3rd, right? You can similarly, you can run an aggregation query and simply count number of transactions per day, right? So let's see how many total transactions were minted by the sequencer in the past 3 days, right? It's going to take a little while to sum up, right? So this is a very nice statistic that you can run all the way to the beginning to block 0, but here we're limited to 3 days, right? What else you can do? You can do all sorts of analysis here. For example, I'm looking for the top 4 most popular functions, right? So basically, everything that you can do with SQL, you can do here, and you don't even need to know SQL, right? You can simply put together a GraphQL query and consume the results. Now, you can consume the results in this IDE, right, and study it, but every query that you use in the IDE can also be sent right away against the HTTP endpoint, right? So I'm going to open I don't know if you guys see my screen. Just give me 1 sec, please. Open documentation. Right here, it's for now it's just a simple README page, a lengthy README page on GitHub. So every query that I showed can also be sent against an HTTP endpoint, right? So here I'm using curl. You guys don't see my. You guys see my terminal? Let me change that.
Nope, we do not.
You don't, right? Okay, just give me 1 sec, please. All right. You should see an Ubuntu terminal, right, where I'm running a curl command with the same query, right? And I'm going to pipe it through JQ, and you see very nice JSON output, the same that you saw in the ID, right? So that gives you an idea of how to use it in your web app. I don't know if your hackathon involves a web application, but pretty much all the data that you want to present to a user, you can get by calling an HTTP endpoint from your front-end web application and present to the user. So I hope that I made some sense with my examples, and let me open for questions, and please let me know if this can be useful in your hackathon in developing your applications.
Thank you, Oleg. This is awesome. I just had a quick question, two questions. Are projects using this at the moment? And just a second quick follow-up question, what are the differences between this and something like Checkpoint?
Well, Checkpoint, I mean, it's a great effort, but Checkpoint is it's a library. It's a library on a, let's say, on a much lower level. Checkpoint lets you listen for events of your contract, and then it stores your events in your own database. Right, so you would need to write your own code. You would need to run your own separate process to subscribe to these events, get them, decode them. If you need to analyze them, you need to store them and sum them up, and then store it in a relational database. Instead, we will already do this job for you by collecting all of the events emitted, all of the transactions, all of the function calls and its inputs, and we'll put it in a relational database, decode it so that you can query it right away.
Perfect. Thank you. Can't wait to use it.
Thank you. Any other questions? Well, the indexer is open to the public right now. It's an alpha stage. There's no user authentication just yet. It's simply open. So go ahead and use it, but please don't abuse it, right? So try not to bring it down. Like I said, it's an active development, but it's up to date with the latest blogs on testnet. And if you have any questions, hit us up on Telegram. On our website, which is just a landing page, on top there should be a link to the Telegram group where you can find me and my colleagues, and we'll be happy to answer your questions online. Right. So right here in Talk to Us, you can just get to the Telegram chat where we hang out and answer questions. Okay. Well, thank you very much for your time. I hope you find it useful, and I hope that you use it in your hackathon and further in your development. Thank you.